Happy, right?
All right, welcome everyone. Let's start off with any questions on the homework. Haley.
Can we go over number 5? 24, sorry.
24, problem 5.
Yeah.
And any particular part of this?
Yeah, I just want to make sure.
Was there a particular part of this problem you wanted to talk about? Okay. Yeah, so here we are looking at the age categories of drivers. And we have who are in a crash, and we have known percentages of licensed drivers that fall into each of those categories. So we're comparing a single categorical variable with 4 categories to a set of known proportions. So that's going to be a chi-squared goodness of fit test. So to compute the test statistic, we need to first compute the expected counts. So under 25, 25 to 44, 45 to 64, over 64. So let's fill in the expected counts. How are we going to compute the expected count of the number of crashes in the data set that would involve a driver under age 25? Sarah, what can we do?
Don't you take that when we do 10 and multiply it by the percentage?
Yeah, so n times p, like the mean of a binomial distribution. So 210 times 0.16 for the 16% written as a decimal. So 210 times 0.16. What does that equal? $33.6. And similarly, for the 25 to 44 age range, we'll have 210 times 0.44. And 210 times 0.27. And 210 times 0.13 to get our expected counts. So then, what is our test statistic for a goodness of fit test? Everybody find the formula for the test statistic in your notes and show it to the other people at your table.
Wow.
All right. So Kaylee, did you find it in your notes? What is the formula?
It's observed minus expected squared over
Yeah, and then we'll take the sum of that over all of the cells in the table.
Well, I don't know, I do it. It's still possible.
So does that feel like the right amount of hint to get you started now?
Yeah, that's perfect. Thank you.
Cool.
Is there a way that you can type in like times 10 to the whatever power? Because typing out like 22 zeros for that 2 value.
Yes, so you should be able to do like 2 star for multiplication, 10 and then caret. So like shift in the number 6 to get a superscript, -7 or whatever it is. That's not the actual p-value, I was just making up. If you forget like that it's the caret or something like that, you can also make use of these buttons on the side. So you could do like this button to get the exponent. Welcome. Other questions on the homework? Here's that. Problem 9. Okay. So for this problem, the nutrition expert has computed the difference between each person's actual weight and ideal weight. Sorry about the weight focus in this problem. Like, this is one that's not from our textbook, it's from another textbook, and it like pushed it way to the end of all of our review problems, and then I kind of ran out of other good problems. So here we are. Bad puns. All right. So we want to test whether the average American is overweight. And the data we have for this is the differences between their actual weight and their so-called ideal weight as determined according to this nutrition expert. So if we started out with information from a bunch of different people with 2 values for that one person, and then we took the differences, what kind of test does that sound like? Say that louder, Sandra. Yeah, that's a paired t-test that we have essentially repeated measures for each person, but the measurement is the actual weight and the so-called ideal weight. So if we're doing a paired t-test on our calculator, the first step is to find the differences. What's the second step? What function are we using to do a paired t-test? Because your calculator does not have a function that's called a paired t-test, right? Yeah, you do a 1 sample t-test on the differences. And here, it's giving us, the problem is giving us the sample mean and sample standard deviation from the differences. So you can do a t-test with input stats and enter the sample mean, sample standard deviation, and sample size. So that's the number of pairs, which in this case is just the number of people, each of whom was measured twice. Tirza, is that good to answer your question, or you want it more detailed than that?
Got that part, but like, I don't know.
Good question. So for a paired t-test, the null hypothesis deals with the mean difference. So we've taken the differences and then we're taking the mean in the population. And typically, what we're interested in is whether the mean difference is equal to 0. And for the alternative hypothesis, let's see. So it looks like we've got actual weight minus ideal weight. So, and the nutrition expert is claiming that on average, people are overweight. So that would be saying that the average difference would be greater than 0 if we're taking actual minus ideal. So that's going to be a one-sided alternative hypothesis. Does that answer your question? Cool. Any other questions about the homework? All right. Any questions about the video you watched for today about scatterplots and correlation? All right. So let's give it a try. Has anybody heard of this illusion where your food looks smaller if it's on a big plate? Today's analysis is looking at whether the size of the white has increased over the course of the 20th century. I think so this is the plate size activity that's right here.
I don't remember anything.
No, it's kind of horrible. Because it's just the name of a year, it's not.
So
It's not that.
year is interesting. Year is a number.
But it's not
And hang on. Year is a number, and numerical comparisons do make sense. Like it makes sense to say that 2020 is twice as far from 2000 as it is from 2010. So it is a quantitative variable. In the past, we have sometimes treated it as categorical when we only had like 2 or 3 years to deal with.
Right, so like it depends.
So it depends on the context.
So is this one, so it's.
So I would treat it as quantitative in this case because we have a fair number of years in the data. If it were just a
So
couple
for
of
2
years,
years, you just straight up say that.
then I'd probably treat it as categorical, even though it's technically quantitative.
She's like, oh, not my bad. Okay, diameter, that's also. Once you get, there's so many. It's like ages on it. It's like.
Yeah, no. Like 10 years old, 9 years old. It's just like,
I think it's like that in me.
I know, that's what I was saying.
But we're not. There's 2 different case signs. We're on J.
And the screen?
Do the 10.1 first and see what it looks like. Look for, oh, we don't even know how many samples are supposed to be in it.
So
Maybe it's the same data.
Does it say year? Well, which one were you looking for year? 2010.
We don't even know how many.
Look at the other ones.
Diameter.
It might just be the same data.
No, it's definitely. It's a temporary.
It would be more common. That's.
Which one was big? Like that's why I think. That's what I was thinking.
Which varies.
Yeah, I know. It's just the model. It's just the.
This is the model of the plane.
You're not-
Well, again, we don't know.
more variables there, we actually want to batch this. Oh, these years are.
So.
It can't, but that's not fair.
Your girls don't know.
I think it's positive.
It is positive. So what are we guessing for this? 6?
We have to.
One, or positive.
Most of this
Oh,
just
wait,
describe the direction.
So it's linear.
Yeah, so it's positive.
Yeah. And then fourth, would you describe it as acceleration?
Hey, it's all for number 2.
No, I thought that was.
That was number 2.
The strength is like the number, so I think it's.
What variables on the x-axis?
As a moderate.
Maybe moderate.
Yeah, it's definitely moderate. It's a grody state.
Okay, so what would
Mark my pencil on it.
week would be like if it was so spread out that.
That's it. Yeah.
Weak.
Like if there were like more points on the bottom. Check the box that says quantity. Don't follow the trend or.
Yes, it
that's
is.
fine.
Your assessment.
So, yeah.
Wait,
Oh, no, it's just point, no, it's just point.
Who said negative?
Oh, I thought that.
Oh, Sarah said negative?
Yeah. I was just seeing if you guys are paying attention.
Guys, is that right? It is not.
Yeah.
Well, of course it's moderate. Look at my graph.
Okay, JJ.
Yes,
it's barely over.
positive. It's also positive. No. So we were correct. Are there any? Is that?
That's 0.6 though. Yeah.
You did.
Unusual or like extreme values? There's no.
So what's it just R equals?
Yes.
No. So you.
I doesn't agree.
Yeah. No.
I said no.
It's fine to me.
I said not really anything noticeable.
You said that.
I'm saying.
You guys would know.
Why do I say about this if it's wrong? It's like you're wrong.
Yeah, but I'm
it's not
confident there's nothing wrong with it.
And I'm like, I'm sure, but like.
So you look at that, you think there could be something wrong.
I don't know, that's what I'm saying.
When you make it look like that, then how can you be wrong? So it's like, it's R squared.
Not really sounds like you know what you're just talking about.
This is like confident, like,
I know, I'm not-
I'm right.
I don't like to be confident.
Where's the app? No, so it's.
Yeah.
I'll take.
That's not.
Scroll down. Scroll down.
This is all.
Keep going. That it?
Yeah.
To see ad though.
Yeah.
So I was right.
So it's the date.
We're not really.
Oh, yeah, right. Oh, yeah. Yes, because like, even though it doesn't go with the. trend,
No.
it's still-
Right?
So is it an outlier because it's so far away, or is it not like, if it was like once a year?
Find out. It's really.
Not really far away, the rest of the year.
Yeah. Because it's still on the line.
Yeah. It's not-
So we're saying like, if someone was like right here, yeah, that.
Yes.
It's not just like trying to.
In terms of the relationship between parents and students, so now
I think it's fine.
the points of correlation.
Right?
I think, yeah, yes, like even though it's the, it's like, it's so far away.
Fit.
What is the mean value of the correlation coefficient? Okay, one on the bottom, it's one.
That's more positive.
More positive. Oh, yes. I'm like, I don't know what I wanted.
I'm not sure. From correlation.
You say so.
Okay, and observations. I'd say so it's influential.
I think that's a question.
No, I know, but I'm just saying, if it was a question, we would say.
We're saying doing this.
Oh, observations are extreme with respect to the explanatory, just X. Oh, they, may or may not be a mutual meaning of the I don't know.
We're on number 25.
When is Wednesday?
Isn't that due next week?
Next one.
Like not this week's Wednesday.
Yes.
As in
the
We didn't have
week.
class this Wednesday.
Yeah. I guess it was next time. So we're having.
But that means Mondays.
Oh, no, yeah, I forget it.
I forgot to turn my laptop
I
on.
mean, it's just, many are regretting it, right?
What's environment?
No, what is that?
What?
Wednesday.
I haven't watched.
No.
Like,
that's
for
what
lunch,
it's
right
like.
there?
I had no clue we had that.
When I
I haven't watched the last few videos about watching cameras.
do.
Yeah.
I don't like that.
I don't watch the videos.
Looking up when you do it.
No, yeah, I just look at it.
Yeah, that's pretty.
Oh.
Really?
Should we just do it right after this? We get it done with?
Yeah,
That
we're
sounds
doing
like
library
this.
soon.
You guys are doing the library?
Yeah.
We gotta study.
Gradually don't study. I took away. I took to this reason, what are you doing? I'm trying to watch football. You're supposed to do Chris, why? Why could you do that? So I told her she's the best all with this. So she was like,
Oh, yeah.
"Okay, she's fine with it."
I was thinking for
Oh, that was bad. My thumb's down. Oh, you have a charger with you?
No, I started from the.
Okay. I'll use Chris's.
Can't think look at that from that. It's fear. Look at this budget line, what is that?
Yeah, so it's 25% of.
Alright, how much is this one?
I think it has to be like close to the line. Or 25, so
That's where it's trash.
You know, they're like two different ways out.
I just got this from my grandma's closet.
Yeah, so this is an example of a point that is an outlier in terms of the variables separately, but not an outlier in terms of the general trend or relationship. You can also have a point that's the opposite, that could be an outlier, sort of in the middle. What?
The correlation coefficient only.
Oh, is that what it
She said yes.
Oh, I mean, like Sarah.
I'm the same now.
Just put yes and no.
Not really, that's like, not really. So.
That's an outlier.
That's how much it's.
No.
It's just the.
I
No,
know.
They're correlated. It's nice to be different. Like,
No,
I'm just waiting until she goes through.
if that were a bar graph. it would be-
Is that what you just made sure?
If that were a bar graph, it would be an outlier. So we're just gonna say no. Right, on this graph, it's that.
I'm still waiting for it.
They're elderly. And they have added. I love old bikes.
Oh, take it, Sarah.
Now you have to pull in.
You want to pull it?
Actually,
I'll just pull it.
no, I'm not- I'm good. You know,
I don't. I've been to
That's the strength of the relationship.
Wow, that was right through.
Yeah, but then. Yeah, maybe.
We try to make it best. Keep those.
Do the song.
It's like, I think we're really good. It's like, let's try it.
Yeah, exactly. These are the daily ones. Yeah.
So I want to put yourself in a position. where they can attack you. I don't know,
I don't know why.
She's messing with me. Yeah, I know what it is.
It's a break. You have no mental.
Sure.
Oh, yeah, what is it?
Shit, dang.
Why? It's good. Why? I don't know.
It is though.
You have stuff across.
No, for A and B.
Yeah.
Yeah, it's 2 videos.
To watch? To watch?
Yeah, to watch, and we have lots.
But that's not two. Like, just like, or what?
No, the marshmallows.
Oh, last time.
All right, let's talk about this. Oops. Computer up there. All right. So our variables here are the year of manufacture and the diameter of the plate. Which of those would you say is the explanatory variable? Ready? The year, yeah. makes more sense to think about the year influencing the plate size than the plate size influencing the year. All right. Is plate size categorical or quantitative? Mary? Yeah, it's quantitative because it was recorded in inches. If it had been like small, medium, large, then that would be categorical. And in that case, we would use a different method to analyze this data set. But here we have a number in inches, so we can measure that as quantitative. Year is a bit more complicated. So we have analyzed year as a categorical variable in the past. For one, I can remember the data set about the percentage of people who donated blood in 2 different years. We treated the year as creating 2 different categories for the data. But year is a numeric variable where numerical comparisons make sense. It makes sense to say that the year 2020 is twice as far from 2000 as it is from 2010. So year can be a quantitative variable. And when we have many different years to analyze, then it makes sense to use that information about how far different years are from each other. So when we have many years to analyze, typically we'll treat that as quantitative. Versus in the blood donation activity we did a while ago, we only had 2 years. And when you only have 2 years, then it doesn't really matter how far apart they are. It just matters that they're different years. They create 2 different groups of the data. So when you only have 2 or maybe a small number of years, then we'll sometimes treat that as categorical. But in a case like this, it makes more sense to analyze it as quantitative. Questions about that? All right. So here's what our data look like. And we have year on the x-axis. So that's good. Our explanatory variable is on the x-axis. How would you describe the direction and form of the relationship between year and size? Let's do direction. Would you say that's positive or negative? Let's do thumbs up for positive, thumbs down for negative. Yeah, thumbs up. That's generally a positive trend. So as year increases, plate size also tends to increase. If we get rid of the regression line here, I'd say that's generally linear. There's clearly a lot of noise there. So this is not a strong linear relationship, but there's no obvious curve to it either. So I would tend to say that the direction is positive and the form is generally linear. All right. So the strength of the association. So how tightly the points cluster around that line. Raise your hand if before you looked at the correlation coefficient, if you said this was a strong relationship. Nobody. Raise your hand if you said this was a weak relationship. Yeah. and moderate relationship? Yeah, so if we look at the correlation coefficient, this turns out to be a moderate relationship, 0.6. But like I hear you, if you looked at this and thought this looks like a weak relationship, that can be hard to see. And if you look at a bunch of these graphs, so you'll see some of them on homework, you'll start to get a better sense of what a moderate relationship looks like versus a weak relationship. That you actually can use linear regression, which we'll talk about into the next week after Thanksgiving, in cases where the data set is pretty noisy, where it doesn't look like the points follow a line very closely. And if you want to play around with that, you can check out the correlation guessing game. So here you can have it generate a sample of data for you, and then guess what the correlation is. So let's see, this is going to be a negative correlation. This looks reasonably strong to me. Maybe I'll guess negative 0.8, and then we'll check it. Oh man, I was far off. Negative 0.541. Let's try again. Oh, this is very noisy. Looks a little bit negative, but very noisy. Maybe negative 0.3. So if you want to play around with this, the correlation guessing applet is sort of fun to mess with. All right. Are there any unusual observations? What do you think? So I would tend to say, no, all these observations look pretty much like they're following the same trend. I heard some discussion about maybe this point being an unusual observation, which I would say, I think that's a reasonable thing to say, but in general, it's not that far off of the trend of the rest of the points. So I wouldn't be too worried about that point. Now, if we add a dinner plate manufactured in 1850 with a diameter of 8.9 inches. All right. So our correlation coefficient was 0.6, and our regression line had a slope of 0.0128. Now let's use data again. And here's what our graph looks like now. So this point is definitely an outlier in terms of year and size. It's far away from the rest of the data in each of those two variables separately. But it actually looks like it follows the trend of the rest of the points pretty well, in that it's in a position such that it sort of supports the general upward trend of the data. And if you look at the regression line, the slope actually didn't change very much. It went from 0.0128 to 0.0127. So this is not an outlier in terms of the trend of the data. And that's something that's interesting about linear regression, is that you can have a point that's an outlier in terms of the variables separately. That's not an outlier in terms of the trend or the relationship. Or You could have a data point that's the opposite. That would be an outlier in terms of the trend, but not an outlier in terms of the variables separately. So that would be like if we had a data point right here, like 1970 with a size of 11. Like that would be in the middle of the data for the year and in the middle of the data for the size, but it would not follow the trend of increasing sizes as years increase. All right, so how did the correlation coefficient change when we added this point? Maybe what did you get?
It increased by like 0.2.
Yeah, the correlation coefficient increased by about 0.2. So it went from a moderate relationship to a strong relationship. So that makes this an influential observation where adding it to the data set changes the strength of the association by quite a bit. And that's very common for data points that are outliers in terms of the explanatory variable. That we get that the regression line, this red line here, gets pulled so that it goes directly through that point. And then that's increasing the linearity of the relationship, that there's this point that's right on the line, and then there's a whole bunch of points that are sort of close to the line, off in another position. Sarah?
If we like get a point that's like an outlier, if like that, is the linear regression line always going to go through it?
It's not always going to go through it, but typically a point that's an outlier with respect to the explanatory variable will get pulled toward that point. So like you might see something where without the outlier, like here's our regression line, and then with an outlier, the regression line gets pulled toward it like that. Other questions about this activity? All right, thanks for your good work today. Have a great Thanksgiving break, and I'll see you next Monday. You too.